Here we are. This voice always scares me. Great. Let's give this a try. One second. Here we are. Here you go. Perfect. Can you all see IntelliJ right now?
Yeah.
Perfect.
Will you send us the recording, or?
Yeah, I can upload it to the drive and send a link to it. So that should be possible. Cool. Yeah, but I will also, I can't show because Zoom is a bit in the way here, but I also have like a cheat sheet here to how I solved these issues, which I can send later, or perhaps this, which we will create together. I think that's kind of useful. Anyhow, so for the people who haven't, oh, I should probably check the chat here as well. Okay, great. Yeah, nothing bad. Please tell me if I'm missing something important in the chat, because I will not have it open as I do this. And I will move this down a bit because it's very hard to see. Anyhow, so for the people who haven't seen, bonus assignment 1 contains a README with some instructions here. We have a main class, which is empty with some small advice here. We also have a point class, which looks kind of advanced, but it's very simply containing an X field and a Y field representing a point on some plane, together with methods to return the distance on the x-axis between a point and another, and the distance on the y-axis between a point and another. We also have a line making use of these points. So essentially a line, as we have defined it, is nothing more than 2 points on a plane. And essentially we say that the line is the distance between these 2 points. So we can get the x length and the y length here too by making use of the points methods. And we can also get the length of the line in general. I was cheating here a bit and using the math library. It's very useful. And then we also have a rectangle class, which is completely empty. And this is one of the first things we'll start working with, where we'll try to implement this rectangle class. So let's take a look at the instructions here. Implement the rectangle class fully according to the comments, i.e. add fields, constructors, and implement methods area and circumference. Circumreference is what it said all everywhere before, but I have corrected that. So rectangle class, how should we get started here then?
Start with creating the lines.
Creating lines, sorry?
Yeah.
The field, yes.
Fields, okay, great. So we can create some lines like this, you say?
Yes.
All right, let's try that. And how many do we need to have?
4.
Point.
So did someone say point?
The first of all, if you'd like to call the rectangle from the main method, you should do the first of all to make constructor for the variable, because enter the variable from main to the rectangle. This is the field.
Yes, but
So
yeah, it was asked to create some.
Yeah, but I see if you this is a line like a class, or point like a class. You get my point? The first of all, the rectangle need field. So the field coming from main, the method main to the rectangle. Within, we calling the class line, the class point.
But the point class is already, it's been in a line class, right?
But this is rectangle class, calling a class line. Why private line? The same.
So what would you suggest then that we do instead?
This the first of all, if you you start from, yes, this is correct, but Also for line before line, I think the first of all the value for field, for example, x1, a1, x2, a2. Well, then this is
You want to create them here in the main method?
yeah, this is the main method we're calling the user to enter 4 points, for example, x1, a1, x2, a2. And then this is the point to send to the rectangle to create a rectangle, you know. A rectangle, the first of all, we create the point because you should to have 4 points.
Yeah.
And this is after point, we should like, you know, to make line between 2 points.
I understand what Nuri is saying, but I think the point of I believe the point of this assignment was to for us to work, you know, the coding at different level. Plus, it helps us kind of using one class through another one. So I think that's, otherwise I understand. We could have gone straight away using point in the field of the rectangle class.
Rectangle.
But for the purpose of practicing, I think the assignment was set up this way.
Yeah, exactly. This is, you know, if you like to start point by point, you know, this is to start the first of all to draw rectangle. You have 4 value of point. For example, x and y. You should have x, y, x1, y1, x1, y2, x2, y1, x2, y2.
So step 3 here will be that we will start creating these using the different classes that we have created. But first and foremost, it can be useful to actually take a look at the classes we're trying to implement here. And what the Corey said there was a very good point, that in the line class, we are using the point class before to store some of its fields and remove unnecessary you know, complexity for this class. And then we can do the same for the rectangle class by adding these lines here, as mentioned before. And then we can try actually creating these lines after we have finished the rectangle class here.
Line 3.
Yeah, thank you. Beautiful. So,
line 3, yes.
This should be, I mean, we're doing this one kind of late after last week, so I hope people feel a bit comfortable using this, but we can move on perhaps and see what more do we need to do in this class.
Well, the constructor there.
Mm-hmm.
That's what I told you before, the line you should to have point, because line need point.
So do you want us to get points in here?
Let's create points in the main
Yeah,
class.
exactly, because we have the class point.
So you want something looking like this, if I understand you correctly.
Let me, you know, to tell you it's I don't know. This is okay, but if you would like to make easily,
okay,
calling the, you know,
then we are modifying the exercise. We are modifying the exercise. I mean, I don't think it's necessary that we have to build a rectangle, but it's an exercise which is there, and there are questions that are asked, and I think we need to answer them.
Let's cheat a bit here. Let's create these points out here instead, and then we have them. Whoop. And you know, I'll give you
X and Y.
Yeah, I'll give you a bit of a. Usually in computer graphics, this is the y-axis. It's turned downwards, right? But we will, for the sake of, you know, not confusing people too much, we'll make the y-axis upwards, which is typical, and then have the x-axis here, up. And then we have a few coordinates here for these variables. What do we have a suggestion for a rectangle?
Exactly.
Yeah.
This is the first point. Come down from this. No, go down. this x1, a1, for example. This point x1.
1, 1.
Yes, 1, 1. x1.
1.
1. Yes, exactly. 1. Also, this 1. 1, 4, for example. What do you want?
20.
Sure.
Yes.
So important to note here,
Example,
it is not required to make sure the rectangle is actually a rectangle. We will do this properly, but we don't have I was thinking about adding an advanced method to check that. And I saw that some student actually did a method which checked whether it was a rectangle or not.
yes.
Anyhow.
Why I need to write x1, y1? Because you know if you need to number is difficult. If you need to x1, y1, you have only 4. x1, y1, x2, y2. That's it.
Okay. So
20.
what should this coordinate be? 20.
20.
Ooh.
4.
20,4. And then this one should be
1.
1.
1.
20 here. xy. 20.
Yeah. 20, 20.
Here we go.
1.
Nice.
1.
Now we have this little rectangle we want to create. We will do that later in the main class, but this is the rectangle we will be using now. Let's take a look back in the rectangle code. So you suggested, Nuri, that we send in 4 points in the constructor here, if I understood it correctly. Do we have any other suggestions on how we could do this?
No, I think we need to send the lines.
Yeah, send the lines.
Yeah.
Yes, we have a little comment here from me.
Yeah, I mean, it's like you're going to an exam and they ask you to do one thing and do something different. So
yeah, let's keep doing this. It's good that you mentioned receive 4 lines here, right?
Yeah.
So we could get these points here, as you say, and then we could create, for example, line. We can say that line 1 equals new line P1, comma P2. This is a legitimate way to implement a constructor. However, the instructions here has told us that we should receive 4 lines instead. But this is a completely valid way to do it and would perhaps make life easier in some aspects as well, because you remove a lot of that complexity which can go wrong outside of the main method from this. Anyhow, so this is what we were asked. Oops. Ooh, nice, great. So what should we do then? Perhaps we can call these L1.
Yes.
I think it's easier. Yeah. Sorry?
No. So this line. Is it?
Yeah, this dot
This
L1.
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 equals L1.
This L1, yes.
L1.
L1.
Because this is private.
Okay. But here we're having some issues.
Yes. Because it's not violable. It's a class.
The first
okay.
one. Line.
Give me a second here. Sorry. I think this is just stupid stuff. Yeah, there we go. Yeah. Sometimes it hasn't, when you open a project in IntelliJ without importing it a certain way, which I didn't, then it hasn't seen that the line class was there. But now we have made sure it's visible. Yeah.
I've been struggling in the beginning.
And then I assume we repeat this for the idle lines. Does that sound reasonable? Yeah. Nice, beautiful. So here we are receiving 4 lines as stated and storing them in our fields. Now we get to this spicy method here. You have to excuse the formatting. It's I wrote this in a text editor. So what do we do here?
all plus LN, L1 plus L2, L plus.
L1 plus L. Whoops.
Put in the return.
But we need to have the length
But-
also, right? Length method from the line class.
Yes.
Length method. Okay.
Yeah,
Length.
I think that here we need length.
Yeah.
So
that-
something like this then.
Yes.
Yes.
Not length.
Okay.
Length. And put it in the return.
And then we want to make sure to return this, right? As I heard someone say. So we could store this, but the lazy man's approach is to just do something like this.
But don't we need to apply some conditions?
In what way?
Like they need to be greater than 0.
No, I guess.
Oh, no.
Because it's your.
We need, sorry, just to check what you mean here. Should we apply conditions to each of these or to what we return?
I think that should be
Yeah, I'm saying yes. The thing is, if length is 0, then we can't calculate the circumference. We don't have any rectangle.
Because
Very
you're
true.
giving the points, right? So it's you who's giving the points.
But it's very true that you should check this in regular circumstances, but keep in mind that we have now assumed that the input we will get will be a rectangle, right?
Yeah.
A line with length 0, if you try to shape a rectangle with that, you'll get a triangle. Do you get my point?
So it means that we assume for the sake of the exercise that
Yeah.
we have a rectangle.
In the updated README I have made sure to specify that so that's clear. And I've added exercise 5, which should protect the data to make sure that what you're receiving is a rectangle, right?
Okay.
But this is very simple. We don't need to have more than that. What we're doing here, in case it's not intuitive, is that we have these points, right? And we will create a line object using each of these points. So we'll have a line 1, L1. We'll have L2. Oh, someday I'll learn how to draw a straight line. L3. And
SDA 100.
I'm thankful for this tool though, it evens it out. L1, L2, L3, L4. And thankfully, they have some support with a method called .length. Wow, now I'm doing cursive again. .length, which is spelled exactly like this. So when you're using L1.length, what essentially happens is
You should make
the program moves to the line class and finds this length method, which returns, and this is using a very lazy function called math.hypot, which calculates the hypotenuse between two values, of two values. So and the two values we calculate is the x length and the y length of the line. So to understand this, we can take a look at the line here. Let's say this is our line. And this is our axis. This is just math mostly. So don't stress too much about this. And what we get when we use x length is this distance. And what we get when we use y length, oh, yes, almost. There we go, y length, nice. And what we're doing, so essentially each point calculates the difference between the x values and returns that when you call the x length method. And each point, let's take a look at that. So you used 0.1 and it calculates its distance on the x-axis, 2.2. And you do the same for the y distance. Math.hypot just uses Pythagoras theorem to calculate what this diagonal line here is.
Square root of x squared plus y squared.
Exactly. But we don't have to know this. We just use the other method someone has given us from before. Super easy. Anyhow, let's go back to rectangle class. So what we're doing then is that we're getting the length of each line and just adding it. That's simply the circumference.
Yeah, excuse me. You have to do also for the line to calling 2 points to create the line, one line. Now this is create. This is for rectangle, 4 lines, but without building. If you go to constructor rectangle, you have 4 lines.
Mm-hmm.
But what do you do with this? The line you should calling 2 points, right? From point plus point. For example, line equal new line, 0.1, 0.2.
Yeah, one approach is to, as you say, receive the points there, and then you can do some work using that, if I understood you correctly. But since this exercise is specified 4 lines, yeah, yes. we are forced by the technical description. Some boss, without understanding that this is much more efficient with points, have told us you have to do this, and then we're stuck.
Yeah, exactly. But if you write L1, for example, equal new line, 0.1, 0.2. You get my point, for example. This is means 4 lines. Because the line is calling 2 points, 0.1, 0.2, new, yes, 0.8, 0.2.
New point. You want to create new points here?
No, this is a new line equal 0.8, comma, 0.2. This plus. This is the one line.
Yeah. I'm sorry, I'm not. What was the question?
This is create one line, you know.
Yeah, absolutely. But we will start doing that in the main method then. But this is how you create that, exactly.
To get your point here in the constructor, you should to receive and store 4 lines. 4 lines mean this is the line. You get my point?
I'm very sorry, but I'm trying to, because we're receiving the 4 lines here, right?
Yeah.
Yeah, I mean, the way you want to create the line, like, because the question is saying, receiving 4 lines, and the way you want to create this line is by the method specified at the last line there. So
yeah. And then
I think Nouri wants to receive us as a points, I guess.
Exactly.
Yeah, but we will do that in the main, Nouri, I guess.
Yeah. We will create all the things we need out here then in our little play area. Does that sound good?
Exactly, but in the Java or any languages, the main only give you the screen out or the system that outline. All the actions you should inside the class. The main give you the interface output of the action of the classes like this.
Well, we can't really assume that. There are scenarios, perhaps we should have another constructor as well, which accepts that. But there are scenarios where, for example, these lines have been created elsewhere and we want to combine them in different ways. And then it's useful to have a constructor like this as well. So like, it completely depends on what the technical requirements are. But I get you. It's probably a nicer way to create it, but we're kind of, someone has given us this technical description. This is what they want it to look like, and we're just saying okay. So, and then we don't think more about it than that because
you are the boss here.
Yeah.
Who is this person? Can we talk to them?
Yeah, it's some stupid teacher, Anyhow.
Yeah.
Great. Let's get to the area method.
L1 dot lengths multiply L2 dot lengths.
Yes, I mean, this depends on how we define things. So this one is perhaps a bit difficult for people to, oh, Marta?
I want to understand well the use of this in this public rectangle, because I was
Okay.
thinking about it. That this keyword is confusing me sometimes.
All right. This is good because this came up a lot, and this was one of the reasons I kind of put this together this way. And now I said this like 4 times. Don't ignore that. Okay, we will do a little thing here. We'll actually create a few points out here and try to think about it this way. So let's create a simple point. Point P1 equals new point. And we said, what were the coordinates?
This is depend on you. Do you want
1, 1.
1, 1.
Oh, this is the issue.
And then we can do point P2 equals new point
Also,
1, 4.
4. Great. And let's create all of these points we're gonna need actually. Let's get this done already. Point P3 equals new point
24.
24. Okay. And then our final point will be anyone?
yeah, but you know, that's why I ask you. You know, this is to do. You know, to calling the user to enter this value. You know, and after that, calling this value to the point.
Yeah, we should probably have like you can create something called factories, for example, to produce a lot of these in a good way depending on user input. But we're not gonna do it like that here.
Yeah,
Anyhow, so let's think about this for a second here. When we create, for example, L1. So could someone tell me how we create a line now, first and foremost?
2 points.
Yes, point 8, point 2.
Something like this?
This is the first line. And then point 2, point 3.
Okay, nice. Yeah, we'll get to the other lines soon, but let's take a look here then. When we're receiving, I'm wondering, is it easier to look at this one or is it easier to look at the other one? Yeah, let's start with point. When we're receiving, you can see here that every point has the fields X and Y, right? And when we're receiving X and Y, you can access X and Y from anywhere in the program. If you're in here, you can do X equals 5. I mean, now it's complaining because we can't reach this due to us returning here, but if we move it up, you can always access these fields because even if it's private, it just means within this file, we can access them from anywhere. However, when we have, for example, a parameter in either a constructor or some other method here with the same name as these fields, the parameter will take precedence, all right? It exists within, does anyone remember what this was called?
Block.
Yes. Well, within the context. There is another word I was looking for as well.
Constructor.
Constructor.
Yeah, but within that block of code, essentially. So if it's within one of these, like for example, as a parameter in a method or constructor, it will take precedence, which means that if you just write X equals X, what you're doing then is that you're trying to give this value X its own stored value already, doing nothing.
No.
What we have to do then, if we want to specifically access the points of this instance of the point class, right? If we want to access these fields of this instance of the point class, we have to write this. The keyword this always refers to the current instance the code is executing within. So if we take a look in the main class here, the program starts. What's happening? We have a line counter here. We're going through line 1. Oh, it's just a comment. Line 2, it's just
a different name. We need not use this, right?
Sorry?
Constructor. The parameters have different name.
Yeah, you don't have to do that then, but usually it communicates quite clearly what you're doing when you have the same name. And there's other instances you might have to use this as well, which you will know them when they arise. Anyhow, so when the program starts, it will start executing. It finds the main method, bada bing, perfect. And it starts going down. It says comment, do nothing. Point 1, all right, point 1 equals new point, okay? And then it sends 1 and 1. So then the program jumps in the code, whoop, up, here, okay? The current instance we're in, we're executing the method here, the constructor here, but we're in this instance of the point class when executing it. And when we are in this instance, the word this will be referring to P1, right?
Yes.
So then it moves further, it finishes the constructor, and then it jumps back in the code and moves to next row. And then it goes and does the same thing again. It jumps to the point class, and it comes to this row and it says this. Oh, so we're referring to P2 now. And then you're writing, so essentially you fix the value for that. And I think last time I showed some of this, I probably should have recorded that session because it was actually very communicative compared to now. But we'll give it a shot.
Excuse me, I would like also to tell you, if you have static is the main and the class has a private, you cannot, there is a problem between static and private. And the private cannot, show it in the main. That way, how can the main will access the field of the class if it is or they are private? That is beautiful to use this is or this.
Okay, in general, and I'll kind of deflect this question slightly. And the reason is because you in general, it's very rare that you use, static in the classes you create in general. And it's even more rare that you have a private variable, which is static in a class. Yeah. It is incredibly rare. It's not something I've seen people implement a private static variable. It's usually public static something. But yeah, so that's kind of my deflection here. It's very rarely done, and you usually shouldn't design your program in a way where that's necessary. That's my very quick cheat here. But can you please kind of perhaps write it in the chat, and I'll perhaps go back to it later so we can, since it's not currently in the exercise. What I wanted to show here, essentially, is that, let's see here. So we have P, let's say that this here is our memory. Nice. And we have P1 in the memory. Now with P2. P3 and so on. Bum, bum, bum. Whoa. There we are. And so if I remember correctly, this was 1, 1. And this was 1, 4. And then we don't have to deal with these. There we are. Nice. So essentially, when the program is computing, it stores all of these things within the memory. You can imagine it like this. And when the program then gets here, it also has a slight it has a contextual memory here, so it sees also, oh, we get some values to this method, x and y, which in this case are, let's see if I remember correctly, 1 and 1. Yes. So when it's looking here, it will, and sees an x, it will always first look at these to see what the value is. But when you write this dot something, then the program will jump to the place it's stored in memory, this, bada bing, and then you write dot x. Let's do a little segmentation here as well so it's clear. Then it does this dot x and gets that field from the memory. This was perhaps a bit long-winded answer, but does that clarify what is happening?
Yes, yes, very good explanation and drawing. Thank you.
Okay, perfect. And then, yeah, I mean, in the second iteration, the same thing will happen. The this value, which is coming here, is an address to P2. We can actually try to print the address later if you want. The address to P2 essentially saying where in the memory is it stored. And then the this will go, ooh, it's stored here in the memory. And then it will say .x and find x. So the this will always be the address. And these values are essentially, it's a little buffer you can imagine, which is sent to the when the method is executing, and the buffer is then removed, as we talked about before. But this is just this visualization of what's happening. Yeah.
Johan, sorry, before we go further, since this is at the beginning of the this assignment, I don't know if it's a matter of notation, but for example, if you take any point, they say P point P dot Y. Is it a matter of annotation? What is that? What is that for? I was kind of
P dot. Oh, okay. This one is also nice. Let's remove this so I can actually read my code. Okay, great. So this is a bit of a cheat. So we've kind of talked about what private means a bit. We'll talk more about it next week as well. But essentially it means that you can only access this variable within this file.
Okay.
People say within this class, but you can say within this file. What we're doing when writing p.x is that we're receiving the point p, but since the point p class-wise is defined within this file, we can access its fields. If we received the line here, we couldn't. If we received the rectangle, we couldn't. It's just because the object we are receiving is of the same class as the one we're executing currently.
Okay.
So p.x will, whoops, let's remove this. Let's say p is p2 and we're currently in p1. Then what's happening is when we write p.x is greater or equal to x, it will see p has the address of p2. So then it checks, oop, oh, thank God we have the arrow thing there. Okay. And then it takes .x, and then you see the regular x. Since there's no x in the parameters here, it will know that we're referring to this. It's kind of hidden, but it's actually seeing it as this.x. And this has the address of P1, which means we're going here in memory, and then we're getting the x from there.
All right.
Does that make sense?
Yeah, yes. Thank you so much.
Super. I'm thinking whether I should save this image or not. Let's move it if it's possible. Yeah, there we are. Just in case we ever need it again. Okay, great. So where were we? We were in the rectangle class, right? Now, we have the difficult task upon us to calculate the area. And what I wanted to specify here is that the area we're trying to calculate, I mean, it completely depends on how we have defined these lines outside. Usually, we put some restrictions on the in data. I saw someone, for example, having a public Boolean is rectangle. Whoa, caps lock. There we are. With some code here. Nice. And then you can essentially do such a thing like return false. Let's do this. A simple way. This is probably, if you have to do this, sometimes it's a bad design, but an easy way to use this then, and this is probably what I'm going to add to the next advanced exercise, is to check if, and then we receive L1, line L2, line L3, line L4, something like that. And if it's not a rectangle, L1, L2, L3, L4. One easy thing you can do, whoops. Whoa. I wonder what I open now is to just do something like this. We'll talk more about this later on, but essentially what this does is that it throws an exception, it stops the whole program, and usually you add some text here to clarify what the problem was. So that's one way to handle that, but usually you have to define your arguments in a way that you don't have to end up in a situation where you throw this. This is kind of the difficulties of design. So this design choice to have 4 lines as an input forces us to do something similar to this. Yeah, but that's an easy way to do things. But to get back to the actual method, we will assume that we will get the lines in the order that we drew here. L1, wait, sorry, this is not actually correct. Is there an erase button anywhere? Nope, okay. Oh, beautiful, you can do this. So we will assume that, I mean, it's completely up to you when you implement this method, how you want to define things, but just to make things easier for us, this will be L1, this will be L2, this will be L3, and this will be L4. Yeah, sounds good. Now then, what do we do here?
L1,
L1, L2, since the 2 sides are same here.
L1, what?
Dot length
multiply.
into L2 dot length.
Yeah, perfect. It's not more, whoops, difficult than that. We're taking the length of L1 times L2, and that's how you get the rectangle of a, no, the area of a rectangle. Great. Perhaps in the meanwhile, we want to try to actually create one of these rectangles. So we got started here a bit before when I wanted to show this. I can probably just do this, whoops, the easy way. So for these different lines, what should the input be to these, to L2, L3, L4?
L2, P2 to P3.
P2, P3 like this?
Yeah, P3 to P4, L3, and P4 to P1.
Yeah, okay, great. Now then, we can actually get to our rectangle. How do we do this?
Yeah, lines you have to give here.
Yeah, it's essentially giving us the answer here. We don't have to be very good designers for IntelliJ to just help us out. Thankfully, we have names. Whoa, did I close it down? Command S always between every line you make to save things. Anyhow, we have a rectangle. Nice. Let's try this out, perhaps. So we can perhaps try the circumference. Anyone who wanna try to calculate these things before we print it? So we simply call problem methods, and yeah, what do you think will be printed?
This is you give us only point. We should calculate the line before. We have only points value.
Only point values. Uh-oh. So what will the output be then?
Yeah. For example, it says this go in the okay.
I'm not hearing any answers.
I think for the area,
Circumference in the area.
3 multiplied for 19.
Okay, perhaps I can check in the chat meanwhile here. Perhaps I missed quite a lot.
Area 52.
Someone asks here whether we have to check if L1 and L2 are the same length. Would you mind explaining what you mean?
I think they meant L1 and L3 and L2 and L4.
Huh. If you pick two short sides. Well, okay, we have defined the output for eventual users of our class here. Simply that you have to give it in this kind of order that you go the lap around, right? So no matter what kind of rectangle, if you start here, that still works. No matter where we start, that's fine. But this is how we specify the usage of our rectangle class. We can enforce it, as mentioned before, with exception throwing or other types of inputs, but this is not the point of this exercise. Yeah, Nuri?
This is,
Yeah.
we should to know for the method, if you go to the class line, you find the math.heap2, can you?
Sorry, class, wait, one?
Class line.
Yeah, go to the line, okay.
And you find here for the math dot. This is, you know, to give us the line.
Yeah, this gives us the length of the line, yes, but we don't actually have to do these kinds of calculations when we have defined a very simple rectangle like this. But let's try the program and see if I get this straight. Let's check in the chat here. If I can get the chat open. There we are. 16 plus 16 plus 3 plus 3, which would be 38, right? And then we got 3 times 19, which should be 57. Easy peasy. Let's give that a shot.
I think the area 27. So 3 multiplied 19. I don't know.
Wait, sorry.
Yes.
44 and 57.
Yes, 3 multiply 19. That way you will give 27.
Yeah, all right, great. People got it right.
Yes.
And it looks like we're doing something right with the code here, which is very confidence inspiring. But then I'd like to ask you now, because here it gets a bit more tricky. Let's say we want to try to create a triangle class. Now, this is the first class you have created, right? You haven't had a week more here to train. So how do we do this?
It seemed like taking the 3 points.
Sorry?
Are you asking about how to create a triangle?
Yes, how to create the triangle class.
Yeah, we can take the 3 points.
Yeah, point 1, point 2, point 3.
3 points, and we can make 3 lines out of it.
Yes.
Okay, sounds good. So this is the whole rectangle session. Let's create 3 lines now.
A separate class for that? No.
Oh, you want to create a separate class? That sounds promising. Let's try to do that.
We should to know what the type of the triangle.
That shouldn't be needed because there's a trick to this one actually, which I think some people found. What should we call it? Perhaps just triangle. Sounds reasonable. Now, we're at the blind. How do we get started here?
We can have a constructor.
Constructor.
Constructor, okay. What's the return type?
3 lines.
Constructor return type.
Yeah, no return type
No,
since it's a constructor. Yeah, nice. That's what I want to hear. And then we said 3 lines here, I heard.
Yeah.
Perfect, okay. Awaiting further instructions.
First, we need to have the fields, probably.
Okay. And they should be lines then, I assume. I did a presumptive here.
Private line.
Private line.
Ooh, nice catch. We can't allow these to be visible anywhere. Okay, nice.
And then initialize the lines with this.
Whoa, caps lock. Perfect. Now, what do we do?
I think we need the area of a triangle.
Area also. Yeah, the same rectangle. 2 methods.
Oops. Okay. And what should the return type be?
Int. Double.
Okay.
Double, sorry.
Ooh. And why should we have double here instead of int?
Because we might get,
Yes.
as we are giving points.
Mm-hmm. Let's take a look at the points.
Double.
Yes, exactly. I mean, they store double values within them. So when we do calculations and whatnot, double is usually the type to use, because then we have access to decimals and more exact calculations. So public double
Triangle.
area. Oh, triangle.
Area, sorry, area.
Oh.
Yes. Half base multiply for height.
And now it's totally depend like what type of a triangle we are creating.
Well, and a general triangle.
General triangle, it's like
No.
if it is a point, then I think we need to have the circumference or the perimeter of it.
Okay, so to
And
calculate
the what you call it, the formula of Aaron.
Formula, yeah.
Ooh, I heard something about the formula. I ain't no math genius, so what should we do if we don't know what this formula is?
I think that this simply right.
Normally, you have to know you can use the base of the triangle plus the height. But if you don't know which type of triangle it is, then the general formula to use would be the formula of Aaron, which means we use what do you call it, the square root. Well, first of all, we have to determine the perimeter,
which is nothing but circumference, I guess.
Yes, divided by and we divided by 2. So what I would do is, or what I did was to determine a
double.
Yes, double, whatever, double S, for instance.
Double S, let's try that.
And yes, double S
is equal to?
Yes.
Same L1 plus dot length plus
L1 dot, sorry?
Area.
L1 dot length, yes.
Length, yeah.
Plus L2 dot length plus L3 dot length.
I think this is area. This is not, I don't know.
No, that's not the area at the moment.
The area, if you suppose this is, right triangle, and the area equal half multiply base multiply height.
Perhaps we can get started with the circumference method. Hold your thoughts here. Let's try the circumference of a triangle first, because that's the order we put them here in the rectangle, right?
Yes.
Okay.
Public what?
Right triangle, for example.
Circumference. Up. What should we type here?
Some of the, so that would be return. L1 dot length plus L.
Same value for the S. You can copy there.
Exactly. Yes. This is for.
Very nice that you found this. So what we have done here now is that we see that we have done one of the major mistakes when coding. And what is that? We've duplicated the code. Never. We have saved ourselves the effort here. So we can just call our own circumference method, right?
Yeah.
Easy peasy, clean. And if ever we define a triangle differently and the circumference of it, we have a nice little method here we can always reference back to change. And
Johan, what if we don't need a method? Suppose if I don't want to use a method, can I write the previous line?
Yeah, absolutely. If our requirements now said that we should implement the same methods previously, including the circumference, but if this wasn't, included, I would in this case just have this line here as we did before, if we didn't have a circumference method, because like you'll get the feeling for this eventually with time, like when is it necessary to break out the code and when is it necessary when can you just leave it in like that. You can break it out like this, but then eventually your program gets flooded with methods which perhaps don't fulfill any purpose, right?
Okay.
So I think
So
yes.
it's a balance. Sorry, go ahead.
So I think here we should divide the circumference by 2.
Yeah, the semi-perimeter, semi-circumference.
Exactly. So in the next line, we can write the formula for the area.
Yes.
Okay.
So return, I think it's square root.
Ooh, how do we do that? Let's, for a second, pause. And for the people who don't know, Heron's formula. Firstly, if we want to say triangle, we don't know how to do this originally. We don't want to find something called triangle of sadness. We're looking for the area of a triangle, right?
Jonas put a link in the chat if you want.
Oh, perfect. I mean, that's great. Please do check that one out. But in general, we need to learn how to use Google. And usually they will give us formulas like this, and this is not enough. So then you have to perhaps specify without height, for example. And then, ooh, suddenly we get something here which looks promising. Something called Heron's formula. Then you go ahead, search for Heron's formula. And what do we find? Essentially the calculations we're doing currently, where they show us how to calculate the area just using the different side lengths, right? So remember, Google is your friend. I didn't know of Heron's formula before, I started working, studying this and, putting together these exercises. Then, oh, great, that exists. Then I don't have to deal with a bunch of other stuff. But let's get back here. We want to use the square root I saw here. We calculated S, but we want to use the square root. How do we do that?
You can use the math function.
Math, what is this?
It's a class.
Uh-huh. I don't see any math class here.
It's a class in it's a Java that lang class.
The first one.
This one.
Yes.
Okay, nice. Yeah, so just to clarify, math is a class and it's in some of the standard libraries. It's super useful. Whenever you'll do calculations, you will be using the math class. So it's good to know of. Now, what do we do here?
Yes.
S
minus.
Yeah, S is S times S times.
Mm-hmm.
Open parenthesis, S minus L dot length, close the parenthesis.
Yeah.
Times, open parenthesis, S minus L2 dot length.
All right.
Close parenthesis.
Mm-hmm.
Times, open parenthesis.
Same for length, L3.
And S minus L3 dot length, close parenthesis.
Great, and this is actually
We need one more parenthesis to be closed.
No, I think it's good. It's not complaining.
No.
Because when you use IntelliJ, is very nice to use. So when you add a parenthesis, it adds the end parenthesis as well, as you see. Great. Is that all?
Yeah.
Yes, that's for the area of the triangle.
Beautiful. Now this is looking really good. So perhaps we want to give this a spin as well. I'm just going to quickly take a look at the chat to see what I missed here. Math.sqrt. Well, math is the library with the methods, right? And yeah, the SQRT, we can take a look at it if we want. Oh, yeah, okay, sorry. That clarifies this. Yeah, this SQRT method is nothing more than a method which calculates the square root of the values it receives. Anyhow, let's try to create a triangle then.
Triangle R equals triangle T.
Yeah, I'm going to call it T instead. Yeah, equals.
New triangle.
Mm-hmm.
Yeah, then we can, the lines.
Okay.
showing.
Which lines?
L1, L2, L3.
Okay, beautiful. Is this a correct triangle?
Yeah.
Yes.
Interesting. No objections. So I'm gonna be a bit cheeky here and remove this one. So here we have L1, L2, L3. Would you call this a rectangle? No, a triangle?
No, we need to give the points accordingly.
Ah, we need to do something here.
Yes.
So what do we need to do?
Maybe we can change L3.
Whoa. Change L3. Well, perhaps we can leave it be. Perhaps we can create another line. We have these four. Perhaps we can create an L5.
Yeah.
Yeah.
This is good, you know, for point 1, point 2, point 2 to point 3. This is a right triangle. But what type of triangle? This is a problem, you know.
Something like this, perhaps?
This
Yeah.
like this. Or right, it's easy, simply right triangle.
Ah, the lazy approach is usually the best approach. Nice.
Here, I guess it might be maybe easier to use points.
Ooh, all right. Reuse these points, you're saying?
Yeah, exactly. The same. Point
Okay.
1, 2, 2, 3, 3, 1. That's it.
Perfect. Let's give this a shot then. So, what did you want me to do first?
Point. The same point. We have point before. But only, you know, I think this is 1, 1, we have it. 1, 4, we have it. Only change, you know, 1 point we need it, you know, from 3 to 1.
Okay, so we're gonna create a line then, I assume, between these.
Exactly. Yeah. Line 5.
And we were gonna give it
B3 to B1. B3, B1, right?
Yes, yes.
Yes. That's it.
great. All right. And then what do we do when we create this triangle?
We will create a right angle triangle this time.
No, the triangles. Sorry, did I misspeak?
We did the same before.
This is enough?
Out, yes. This is,
Yeah.
I don't know if you go to the triangle class, if you're okay, finish all.
Well, we're still using L1, L2, L3, are we not?
Okay.
L5.
Yeah, you can't forget about that stuff, because otherwise we'll get some weird output.
Logic errors.
And now it's out.
Great. And then we can just, you know, do this again for our...
T.
T dot area.
Oh, nice, nice. And then we will get... Anyone want to try the area calculation?
But I think, you know, for different thinking, if you give us the result and everyone to do the program to give you the same result.
Wait 1 second.
Yeah,
So it's just a little bit cleaner. Let's give this a shot again. Sorry, what did you say, Nuri?
I say if you would like to, you know, to respect all people thinking, to give us the result of the program, and we do the program to give you the same result.
Okay, how do you mean? I'm kind of curious.
You know, this is a program like the math. Everyone has different things, you know, different what he would like to think, you know. But finally, we go the same the result. That way, if you give us, for example, output the screen, and we think to do the program depend on the output of the screen.
Oh, to replicate the output that I have created from before.
Yeah.
Yeah, that could be interesting. Please tell me more about that later. I'm actually kind of curious how you'd like to see that.
Yeah.
All right, but it feels like we have completed both instruction 1, 2, and 3 here,
That's
unless I missed something.
No.
Well, if I'm gonna be a pedantic, we have missed something very important, which is called documentation, which we introduced this week. But yeah, we're not gonna go there yet.
After the assignment.
We can log off, Johan, and you just continue with the documentation.
No. Now I'm very curious. Okay, so this is the main gist of the exercise. Everyone got this by now. We're 2 weeks in, so hopefully many of these things have fallen in place. But before I go to this one, though, it's very important that, I'd like to hear if people have any questions, like so far. This one is completely extra. Don't even bother if you don't want to torture yourself. And I'm also going to open the chat here so you can see. Any questions?
All good.
I can't get the... Oh no, are we looking at the other one? Oh, whew. Wait, what do I open here? Ignore this one. What the?
Your code is gone.
And this is some other stuff. I have, I wanted to use this to show during one of the lectures, but we didn't really have time, if I remember correctly. There we are, and this one is perfect. This is the one we're working with. Okay, great. Let's open the chat. Any questions? Yes, I will upload this to Slack. Don't worry. Great. I'm not sure how Kabena does it, having the chat open while he's coding. It's very difficult. But I see some people give the correct answer here before as well. Change it to L5. No other questions?
No.
Okay.
Expecting
Sorry?
the next
This is
Yes.
number 4.
Okay, so was anyone able to do this one?
That's the one I was struggling with. I didn't finish it.
Okay. Let's see here. If anyone, let's stop the sharing for a second here, and I can see, please give a thumbs up if you did actually solve it. Ooh, nice. We have at least one person. 2. Okay, great. Now I'm kind of curious to hear from you guys. Oh, wow. Yeah. Surprised face. So how did you go about it when you solved the advanced part of this? And before you tell me, I'm going to share screen this again. There we are. It's quite a simple statement. All you need to do is to try in the line class, in the rectangle class, and in the triangle class we have. You need to create a method called isIntersecting, which receives an object of this type as a parameter, and then check whether this object you're receiving overlaps with the current object you're testing this with.
But the thing is the question is, what are the conditions of the overlapping?
Yeah, exactly. So that's a, sorry?
Yeah, I was kind of struggling to write down, because basically, mathematically speaking, when 2 segments or 2 lines overlap,
To intersect.
They have
There has to be some condition of
slope.
values.
They have different slope, right?
Yeah.
in many cases. So I was trying to write this down through the code, but it was kind of, I have plenty of questions that I was asking myself. So the way you're saying it now, it seemed that it was simpler than I was thinking.
Okay, all right. I wouldn't say it's simple even then, but yeah, perhaps. So the people who did actually solve it, how did you go about this?
Google first.
I can't see if you're writing chat. You're very welcome to talk if you want. Okay, no one? All right. Well, if no one feels confident enough to just give it, you don't have to solve it right now. I'm just asking, how did you get started? What were your thoughts? Where did you go? And if anyone says, oh, Nuri, I think you're muted. I can't hear you currently.
This is, in my opinion, I don't know. This is, we have a 3 figure. That way you should to think about, like the condition, if it is rectangle or triangle or the square. And without add other things, the same, line, the same point, we should thinking to know which is rectangle or triangle or whatever. That's it. This is the example case or while or whatever, or if.
Okay, yeah, that's a good way to start. And I think the easiest is always the best way to start in my mind. So perhaps the line class is a good place to start thinking about these concepts, because if you start thinking how to check this for each and every one of these two, you will have issues. So let's take a look at the line class then. Here we are. So firstly, we can start creating the shell of a method here. Let's create the isIntersecting method. And I hope someone can help me here with how this should look.
Public double intersecting and and as you said, you need one parameter,
which is supposed to be
line.
Yeah, okay. Great. Is this correct?
Well, how?
Is this correct as a start of the method?
Yes. Not sure about the line girl one.
No, that's good, that's good. However, since what is it that we're doing here? We're checking whether something is intersecting, right?
I think the return type should be Boolean.
Ah, nice catch. Because we want to see whether something is intersecting or not. That can only be true or false. Either it's intersecting or not. It can't 0.5, whatever that would answer. So Boolean is correct. And let's create an empty input here, or empty return statement there, so we don't have the red message of doom. Perfect. Now, there's 2 different approaches here to where to go next. Approach number 1 is to visualize this, right? To draw a bit. Oh, we have a chat messages here. Maybe check if new point appears. Yeah, that sounds promising. open. Yeah, great. But let's try to draw this first, just to get a feeling for this. Whoop. Oh no, this is the other window. Wait, how to draw? There we are. Nice. So I'm gonna move everyone down here again, and I'm gonna completely clear this picture if it's possible. There we are. Nice. So what is it that we want to test with this method? We want to make sure that this method returns true when we have some kind of scenario where points are okay, this is a bit ugly. I'm gonna draw this here. When points are intersecting like this, or in any other way, where essentially two lines cross each other, right? And the first way, we can start thinking math-wise if you want. This is the sadist's approach, as I like to call it, where you start essentially seeing, okay. Oh, we have a chat message here. Yeah. I'll keep this open here. Yeah. So an easy way to get started is essentially to think what are the scenarios when they are crossing a knot. We can have a scenario looking like this, where they're not crossing. We can have another scenario perhaps looking like this, where they're not crossing. And how can we tell in these scenarios that they are not crossing? The simplest way to, when you're trying to solve these problems on your own, and you're trying to find whether some things intersect or not, or overlaps in some way, is to use something called projection. Essentially, we take the points, whoops, and we see where on the different axes they are. So this is P1. And this is P2. This is P3. This is P4. Nice. And then you find that this is X1. This is X2. Oh, someone's sending a nice screenshot here. Well, my brain, please correct me when I'm completely out. X3 and X4. And what we always want to do as well is that we want to project on the other axis. So when you're doing this on your own and you're trying to solve these problems, always try to think of it like, where in the X and Y axis are they? So we have Y1, Y4, Y3, Y2. And what you will realize when you're testing these scenarios, this one and yeah, sorry, I'm not gonna, you don't have to do the math here. I just want to introduce the math because I think it's very satisfying and programming goes hand in hand with the math. Sorry, Noor.
But it has happened when you create a triangle. You write from point 3 to point 1. This is, I think you make intersection, right?
Yeah, so, but absolutely. We have to do two things here. So firstly, we have to see what, you have these 2 points of here. From that, you can get the angle of this line, right? You can get how much is it tilted and where does it cross, the y-axis. This is usually, it's math 101. So the simple formula, which you don't have to know, is how we draw it in Sweden is y equals kx plus m. This is how we draw it. So this is the tilt. Whoa. Okay.
Yes, that's the slope. That's what we're trying to.
Yeah, exactly. And this is the watt. You can call it the start value if you want. So two things needs to happen when we're trying to do this. Regular lines, as long as the slopes are different, they will intersect, right?
Mm-hmm.
The only scenario where two lines don't intersect are when they are parallel, like this. However, our lines are, as you know, limited by 2 points here. So they are stopped. So then we need to project them to the axis. And this sounds very difficult, but we don't actually have to do the projection. We just have to see whether these points, as you can see here, are between, for example, these points. If you know that they are between these points, and you can do the same for the y-axis, but if you see that they are between there, like P3 and P4 are between, Y4 and Y3 are between Y1 and Y2, then you know that it is intersecting if the tilt is the same. This is math, and this is fun, but this is not what you have to know when doing this course. So the second tactic you as a coder can try to do is to do line intersection, bada bing, and use Google, super easy. And then you can look around for different Stack Overflow pages, which usually are very helpful. And they can very easily explain these concepts if you're interested, or just give you straight up the code that you need. There's also the third way, which I think you saw someone do, which is just find a library where someone has created methods which calculate this already. Let's see here. Chat.
Math is good for the brain.
Yeah, math is good for the brain. I fully agree. Sorry, Nuri, you want to say something?
Yeah, but when I have read this question, I think after create a three figure, and you should to think if this sugar or figure intersection together or not. That I get maybe wrong understand. I don't know.
Sorry, so you said you understand that you need to check whether they intersect, right?
Yeah,
Like
after we created, the three figure, triangle, rectangle, square, and now advanced equation, if you this intersection or not.
So yeah, the way to think about this for the other shapes, which we will realize later, is that if we implement a method like this, I'm going to remove this for now. I hope that's okay.
Yeah, exactly.
Whoa, that targeted the whole thing. Let's do that. Good. So if we have found that two lines are intersecting, then we can be guaranteed that no matter which shape we are looking at, that they are intersecting as well.
Exactly.
So the way to think about this is when we have solved this very difficult part for the lines, then we can know by just testing every line of an object with every other line of an object. Very nice observation.
Yes, that's what I was thinking about.
Yes. So the difficult part is just finding the line intersection. When that's done, you can do this for any object, right? That's beautiful in its own way. Someone said line 2D, and we have some suggestions here. What method would we use from line 2D then?
This, I think. Where is here? Boolean intersects. Go up.
This
Yeah.
one.
Yes. I think this 4 point, you know.
Okay. If you take a look at this one, though, we can see that the parameters, just by using the overview, seem to be a lot more similar to the ones we are working with currently. So the lazy man's approach is to just import this and use lines.intersects line, and then you're done. And the person who did this, applause to you, you cheated. You're yeah, you're out. No, you did a really great job. You did like exactly what you should do. You shouldn't start thinking about the math. The math is super interesting, but you have to stop yourself. This just saves everyone time and effort. And whatever issues you're having, like these problems, you can almost always assume that the code is out there and available. Someone has done this before you. However,
I thought that you needed us to make some research, not
well,
just.
yeah. You fell in the trap. No. You can do the research part as well, which is what I felt was very fun. Yeah, Google spoiled you. Super well done on the people who were able to find just this intersects line method. But the true nerds in the audience will obviously have drawn this and calculated that it has to be within. You have to project this to the X and Y axis. You have to find the intersection. You have to make sure the intersection is between these points. And, you know, yeah.
Johan, I think this idea go for good for the traffic.
Yeah. Great. I'm happy to. But I can show you. I found the most clean, just for the people who do care about the implementation. I found the most clean calculation when doing this on your own in this beautiful thread. Ignore all of this. The .ccvw method. It was amazing. You can go here and read more about it if you want. Yeah. This is superb. And if you take a look, I actually spent the time and translated that into the line method. Here we go. So I created a little private static method. Okay. It did happen, which I then applied to the isIntersecting method. This is a helper method because this is a mess if you don't have a helper method.
Johan, you get the 3 point, not 4 point. This is only, you should, you know, to focus about all point in the program. Am I right?
Yes, but the beautiful thing about the CCW method is that you send in different combinations of points to the CCW method and then check different conditions between them. Okay. So this is just a beautiful piece of code for the people who are interested. And then we can see how we try this. Let's go, for example, to the triangle class. Now we know that we have a functioning isIntersecting method. Then you can go to, for example, the triangle and just check, does these intersect? Does these intersect? Does these intersect? And just try that for all combinations of lines.
You get two line parallel.
Yeah, does line 1 intersect with this one's line 1, or does line 1 intersect with this one's line 2? And then you check all the lines of a triangle with all the other lines of a triangle.
Yes.
And the rectangle gets even worse. But this is super easy. Then you have to don't think anymore. As soon as you're done with the line class, you're finished.
This is a good idea, you know, for not only for intersection, to search to find something, you know, between one and compare with other in the same program. Because, you know, when you get one line and compare with other lines, if it's this intersection or not, this is also comparing, you know, this is logic.
Yeah. All right.
It's good.
Great. Do we have any like questions on that?
I think after that we should go to sleep.
Yeah, I need to get home and, get dinner with my family. Still at uni. Oh, thank you.
Very, thank you so much for this time.
Can you give us this by Slack, this code?
Yeah, I will send this project to you with the finished code if you want it. And I'll also make a note of the intersecting line method. And I'll make sure to send the recording, which I will stop